Each of the actuators are a normally closed on-off device. The actuators open when they receive a signal from the ECM. Opening an actuator allows fuel to flow to its connected timing or metering rail. In this way, the ECM controls the volume of fuel flowing to the injectors. With the two-bank design and the firing order, the ECM functions fast enough to have individual control of the injectors. These dampers are installed near the actuators to reduce the fuel pressure spikes resulting from the rapid opening and closing of the actuators. Stabilizing the pressure in the common rail supplying the actuators allows the ECM to more precisely control fuel flow to the metering and timing chambers. The cylinder head contains fuel timing, metering, and drain rifles to direct the flow of fuel to and from the injectors. When the engine is shut down, the fuel trapped between the actuators and the injectors absorbs heat from surrounding engine components. As the temperature of the fuel increases, the fuel expands and increases pressure in the metering supply rails. If allowed to build, this pressure would push fuel through the open injector into the cylinder. This would result in increased cranking resistance and hard starting while the engine is still warm. A passage drilled between the metering supply rail and the drain passage in the IFSM, along with a check valve mounted in each metering actuator, provides fuel venting to reduce this pressure. An 0.008 orifice is installed in the drilling to limit fuel flow to the drain passage during normal engine operation. The passages from the timing and metering actuators connect to internal passages in the cylinder head. These passages supply fuel to the front and rear bank of injectors. The injectors for the industrial engine have been redesigned to include a change to the hole size, spray angle, and number of holes in the injector cup. The injection cycle begins with the injector plunger mechanically held against the nozzle seat until the end of the exhaust stroke. The injector rocker lever is on the outer base circle of the camshaft. At this point, all three of the plungers are at the bottom of their travel. After the exhaust valve closes, the injector rocker lever begins to move off of the outer base circle. The upper plunger begins to move upward under spring force. The timing plunger remains in contact with the upper plunger, and the lower plunger remains in contact with the timing plunger due to their respective springs. As the lower plunger continues to move upward, the metering port is opened. Shortly after opening the metering port, the metering plunger contacts the stop in the injector. The upper and timing plungers continue to move upward. Just before the spring guide contacts the top stop, the timing feed port is opened. With the plungers in this position, both the timing and metering ports are open. However, no fuel flows into the injector until the ECM sends a signal for the timing and metering actuators to open. The timing and metering actuators are then opened at the appropriate time and duration to supply the desired amount of fuel into each chamber. The metering fuel passes through the metering check valve before entering the metering chamber. By varying the amount of time that the timing and metering actuators are open, the ECM controls the amount of fuel metered into the timing and metering chambers. Increasing the amount of time the metering actuator is open increases the amount of fuel metered into the injector and injected into the cylinder. Allowing the metering actuator to be open for a shorter period of time allows less fuel to be metered into the injector. As the fuel enters the timing chamber, the fuel pressure travels between the timing plunger and the upper plunger through a groove in the top of the timing plunger. The fuel pressure then forces the timing plunger down against spring pressure. As the upper plunger begins its downward travel and closes the timing feed port, it contacts the column of fuel in the timing chamber. This trapped fuel acts as a hydraulic link between the upper and timing plungers. The upper and timing plungers move down together. The amount of fuel in the timing chamber determines the starting position for the timing plunger. With more fuel in the timing chamber, as the upper plunger begins its downward travel, the timing plunger begins its downward travel from a lower position. This advances the timing. A shorter period of time that the timing actuator is open allows less fuel into the timing chamber. This causes the timing plunger to begin its travel from a higher position, which causes the timing to retard. When the timing plunger contacts the lower plunger, all three plungers travel downward together. The metering check valve prevents fuel from flowing back out of the metering chamber. The check valves stop the initial flow of fuel back out of the injector. However, the plungers move past the inlet ports prior to injection to cut off the flow path back to the check valves. When the lower plunger reaches the solid fuel in the metering chamber, pressure in the chamber rises, resulting in the fuel injecting into the cylinder. Injection continues until the annular groove in the lower plunger bore aligns with the trapped volume spill, or TVS port. This allows the small amount of fuel remaining trapped in the metering chamber to flow out of the injector to the drain line, providing a sharp end to injection and relieving fuel pressure in the metering chamber. At the same time, the timing spill port is open to drain. As the upper plunger continues to move downward, the timing fuel spills into the injector drain line. The ring valve on the injector flexes to regulate the timing spill flow. This elliptical flexing of the ring valve prevents the pressure from dropping too rapidly to keep the lower plunger forced onto its seat. As the injector rocker lever again reaches the outer base circle of the camshaft, the timing plunger is again in contact with both the upper and lower plungers. The downward force of the rocker lever causes a mechanical crush to push fuel out of the metering and timing chambers. Fuel from the injector drain flows through internal drillings in the cylinder head to the IFSM. A fitting near the rear of the IFSM allows fuel to return to the fuel tank through the fuel return line. Fuel from the IFSM flows into the center of the actuator feed rail and splits to flow to the front and rear banks of timing and metering actuators. With a constant pressure at the actuators, the ECM sends signals to the actuators to control the fuel flow to the injectors.